Okay, we're going to look at multiplying monomials times polynomials, which may seem a little bit familiar, but we'll walk through it here now. So the first thing we're going to say is to multiply a monomial and a polynomial, simply distribute the monomial to the polynomial, and for exponents, recall the product rule, which I will write here. So when we multiply two bases with different exponents, we are allowed to add those exponents to one another. So our first example is example 1, and so we see here this x on the outside of the parentheses, and so that is asking us to take this x and distribute it to everything inside of the parentheses. So initially, earlier this year, we looked at multiplying numbers. So we multiplied numbers and distributed them into parentheses. But now we're just distributing possibly variables into the situation. So we're taking this x and we're multiplying it times x. And so something we need to remember is that every x has an exponent of 1 if we don't see another exponent there. So we're going to say x to the first times x to the first is going to equal x to the second, or x squared, and then x to the first times 4 is going to be a 4x. So that is the distribution there. On this next example, we are distributing 5m cubed to everything inside of the parentheses. So we're multiplying it times the 3m squared, the negative m, and the negative 7. So in this instance, we're taking 5m cubed and we're multiplying it times 3m cubed, 3m squared first. So first we have to multiply the 5 and the 3, and together that gives us 15. And then when we multiply the m cubed times the m squared, we can add those exponents and we get m to the 5th. So that's the first distribution. Now we're going to take 5m squared and multiply it times 5m cubed, and we're going to multiply that times negative m. And remembering that m has a exponent of 1. So we could also think of this as being a negative 1m to the first. So when we multiply that, we're going to get 5 times negative 1, which is negative 5. And then m to the third times m to the first is m to the 4th power, because we have to add those exponents. And our last multiplication is 5m cubed times negative 7. So 5m cubed times negative 7. So in this case, we don't have m's in both situations, so we just multiply the coefficients, 5 and negative 7, and we get minus 35, and then the m cubed just stays the same. And then that there is the final answer, and we always want to leave it in standard form with the greatest exponent going smaller. So the next example, so this is when multiplying a monomial times a polynomial or a binomial. The next example is something new for you guys, and I'm going to scroll down here. And it's something called foiling. And I'm going to go ahead and read this here. It says, to multiply binomials, distribute each term in the first binomial to each term in the other binomial. Then combine like terms. And this order of distributing is frequently referred to as the FOIL method. So we see here F.O.I.L is an acronym F.O.I.L, standing for first, outer, inner, and last. So we see this little example here. So we have A plus B, parentheses, times C plus D. So we see this A here, this is being distributed to the C, and that's where we get A times C. But then we also need to multiply this A times the D in the next one. So there's where we get the AD. Then we go to the inside, the inner, right? Inner is B times C, which is plus BC, and then last, B times D. So first, outer, inner, last. That's where the F.O.I.L term comes in. So here's our first example. We're going to take, just like they did in that example, the F.O.I.L definition there, we're going to take the x and multiply it times the x. So that's our first. So remembering that it's x to the first times x to the first. So that's going to be x squared. Then we're going to take x and multiply it times 4. So that's going to be a positive 4x. So that was x times 4. That's our outer. Then we're going to go inner, 2 times x. So 2 times x. And that gives us, so there's that. And then we have plus 2x there. And then our last is 2 times 4, which is 2 times 4, which is a positive 8. So the only thing we need to now finish is that we have some like terms we can combine. So x squared is all good. So maybe I'm going to zoom in. So x squared is good. It has no like terms. But then we have 4x plus 2x, which gives us 6x. And then 8's all by itself, but it's still in the problem, so we have to leave that there. So our final answer being x squared plus 6x plus 8. Okay, so let's go ahead and look at this second example. So again, we're going to FOIL, so we're going to do the first, 2x times x. So 2x times x, and remembering that these x's have 1s on them, so remembering our power rule, again, that x to the a times x to the b is equal to x to the a plus b. So when we FOIL that, we get 2x squared. And then we go outer, 2x times negative 5. So we multiply the coefficients. And if you want to think about it like this, if it's confusing, don't do it. But I can look at this x or this negative 5 and think of it as x to the 0 power, so that when I simplify this, I know that it's going to be a negative 10x to the first, because 1 plus 0 is just 1, or x by itself. So then we're going to go inside and we're going to do 1 times x. So we're going to do 1 times x, and that's going to lead me to just a positive 1x. And then our last is 1 times negative 5. 1 times negative 5, which we know is going to be negative 5. So now we need to combine like terms. So the 2x squared doesn't have any friends. We're going to leave it as that. But then we have negative 10x to the first plus 1x to the first. So that's going to leave us at negative 9x. And I'm not going to write the first because we want to write it in simplest form. And then that minus 5 will just be brought down. And that is the answer there. So hopefully that helps you better understand the FOIL method, multiplying binomials in this example, or multiplying polynomials here. And take a moment to try some of these examples on each of these pages.